Hi, today we'll discuss the metallurgy, and this is basically extraction of metals. Metallurgy involves extraction of metals. In the engineering also we do metallurgical engineering, and that is quite an higher level, but still in the 11th, 12th or the middle level school curriculum we need to know this much: how the metals can be extracted from different ores, and what is the definition of minerals, what is the definition of ores, and how metal gets extracted from the ores, and after mining we find out the ores, and then we go to the crushing, then grinding, then maybe concentrating, and then further reduction, and then finally we will be going to the metal extracted, and then finally purification of the metal. So these are the technical steps we go through, and first I will introduce you the definition of the minerals. Minerals means anything, for a metal, any compound can be mineral which is available on in the earth's crust. But ores are what? Ores are those minerals from which we find the metals economically viably. That means it should be economically viable and should be it should be cheaper in cost, or the cheapest in cost, you can say, for the extraction procedure, as well as it should be available on earth's crust. Obviously there is the minerals. So first we will see the minerals. If we again see the minerals we can say the set, but ores are the subset of within the minerals. So minerals definition, we can say compounds of metal. The minerals, that is compounds of metal naturally available in the earth's crust. Naturally available in the earth's crust is the minerals. And what are the ores? What are the ores? Ores are the minerals from which metal can be extracted economically and conveniently. Economically means that is economically viable, it should be the cheapest cost. Like you should not go for the high heating, that is consumption of the coke or the natural resources or the electricity, etc. So somehow you have to make the process so economically viable so that they can be produced easily and conveniently. And also we should try that the pollution should be reduced. The the environment should not be polluted by large extent. So those procedures we basically take up into action as a metallurgist. So here we will say again another definition of gangue materials. Gangue means the impurities present in the ores basically, and gangue materials generally it is a silica, that is a sand basically. It basically acts as a common impurity. So I have written over here the impurities present in the ore is called gangue material. SiO2 is a common impurity. Now about the ores, if I say what are the types of ores we find in nature, like it can be oxidized ore, it can be sulfide ore. Like oxidized means it can be carbonate, it can be sulfate, it can be phosphate, it can be nitrate. And over here again sulfide, we can get sulfide ores. So also we can get halide ores. Also we get native metals also like gold, platinum, silver, etc. So that's how I have written ores. Elemental ore like gold, silver, platinum in the native state we can get, or the ores can be carbonate, phosphate, sulfide, sulfate, nitrate, and halides. So these are basically common existence of the metals in the ores form. So now I will go to the tabular form of the different ores. Let's say I will start with sulfide ores. Let's say PbS, lead sulfide is a galena. Let's say mercuric sulfide, HGS, Hg+2, mercuric sulfide, or mercury sulfide called cinnabar, source of mercury. Let's say zinc sulfide is written as zinc blende, we also call sphalerite. This is also called sphalerite. This is basically zinc sulfide or zinc blende. And you can go for CO2, that is copper pyrite, CO2 copper glance of chalcocite or copper glance. Not the copper glance basically, not the chalcopyrite, it's copper glance for Cu or chalcocite. Now CuF is called copper pyrite. Basically this we use for the copper extraction in the procedure. And FeS is called fool's gold basically. FeS fool's gold, it is the source of iron. Ag2 silver glance, that is silver glance or silver. Now if it is oxide ores, if I talk about oxide ores can be many, like zincite, ZNO, zincite for source of zinc. Fe2O3, this is the ore we use for the extraction of iron, Fe2O3, red hematite. Then magnetite, Fe3O4. Then we can say Al2O3, 2H2O bauxite. This is also the source of aluminium we use in the case of aluminum extraction. Over here, MnO2 is called pyrolusite. SnO2, tin stone we use for the tin preparation tin stone. TiO2, rutile, we use for titanium extraction, and U3O8 pitch blende we use to produce uranium from this, that is oxide ores. List of halide ores is sodium chloride, rock salt, we use for sodium extraction, sodium chloride, rock salt. Sylvine, potassium chloride, used for potassium extraction. CuF2, that is CaF2, this is fluorspar, CaF2 is a fluorspar. Na3LF6, cryolite, these two basically are used for the aluminum extraction, where we will find that calcium fluoride fluorspar basically acts as the fluxing compound, and the Na3LF6 increases the conduction of electricity. AgCl, called hard silver, used for silver extraction, and this is basically carnallite, KCl MgCl2 6H2 called carnallite, all are halide ores. Now if we go to the carbonate ores, let's say we talk about calcium carbonate called limestone, MgCO3 called magnesium carbonate, magnesite. You can talk about dolomite, CaCO3 MgCO3 dolomite. It can zinc, it can be calamine, zinc carbonate, calamine. So these are carbonate ores. Then if we talk about sulfate ores, very very important is that there is a calcium sulfate 2H2 called gypsum, and 2CaSO4H.H2 is basically plaster of Paris, very important, gypsum. And then magnesium sulfate 7H2 heptahydrated, that is Epsom salt, MgSO4. Then lead sulfate aglasite, this is Na2SO4 10H2 glauber salt. Copper sulfate 5H2 is called blue vitriol, very very important, copper sulfate 5 pentahydrate. I have discussed in the bonding chapter, that in the chapter of structures, where we have found that copper sulfate 5H2 has got 2 water molecules coordinate to copper, which gives basically the which goes out while dehydration in the stage 1, then stage 2 again 2 more water molecules go in third stage of heating, we get fifth water molecule goes out. So this is copper sulfate pentahydrate. Now principles of recovery of metal. I said initially at the initial speech of this subject chapter is that first crushing and grinding, we go for ball mill. Big balls will come, and then it is a big round shaped spherical container in which big iron balls are there, which goes like this and then falls down when it is rotating like this, called ball mill. Crushing, then grinding, and then we go for the concentration. Concentration can be done by froth flotation method, that is for sulfide ores. Also we can go for magnetic separation, we can go for hydraulic separation, we can go for gravity separation. So I have written over here physical methods. In physical method is the gravity, magnetic and froth flotation. Gravity separation, for example, tin dioxide Fe2O3, FeCl2O4 concentrated by gravity separation. Magnetic separation, tin dioxide from wolframite, FeWO4, MnWO4, we recover SnO2 from wolframite. Froth flotation for the sulfide ores we use using sodium xanthate pinyl. I will come in the detailed discussion of this. And then chemical methods, it is basically leaching, for example, hydrometallurgy you can talk about, or alumina purification, like in the process of we can say that the Bayer's process, or it can be your many a Hall Hérold process. So many processes are there. So and Sarpex process for aluminium. And next is conversion of this concentrated into oxide, and we are going to the reduction of oxides. It can be hydrogen reduction, it can be carbon reduction, it can be electrolytic reduction, it can be hydrometallurgical too. So these many reductions we generally carry out for the fourth step, that is a step where reduction of oxides takes place. After getting the metal, we do the purification. Purification can be many types, like zone refining. Purification can be distillation. Purification can be the electro refining. So many ways of pooling. Then so many processes are there for the purification. I'll discuss one by one in this chapter session wise.